Okay, good students, let's tackle this question, which says, which is inconsistent with the concept of isotope. So, what is an isotope? So, the definition of isotope: atoms of the same element. We can take an example of carbon, and carbon, the same element, having the same number of proton and different atomic mass number, which is 14. So now you can ask, mass number is simply the proton plus neutron. We call it mass number, which is 12 in this case. And here also the proton number plus the neutron number is equal to 14. So in any atoms of the same element, their proton number is 6. Here we have also 6. But what makes the isotope to exist is the variation in number of neutron. So we have here 6, that's why we have 12 together. And here we have 8, so that we have 14. As you can see in these two situations, in two carbon 6 and carbon 14, their difference is primarily due to number of neutron. Since mass number is simply the sum of proton and neutron, it can affect the mass. So, which is consistent with the concept of an isotope? Same atomic number, as you can see. An isotope is due to, not because of this one, different number of neutrons, which is inconsistent. It says the same atomic number, yes. The same mass number, as you can see, do they have the same mass number? No, it's inconsistent. Same number of proton, yes. Not only in the case of this one, any given atom. If we define carbon atom, copper atom, iron atom, all of them have got their own atomic number. So that's why we distinctively call them copper, aluminium, iron. So it's their like identification card for the elements, their atomic, the proton number, the number of proton. So according to this question, the answer is D. It is inconsistent when we define isotope. So let's see the next question. Sample questions. It's all about a mysterious element had the following relative abundance. This abundance is given according to, as you can see, according to the information given. It says a mysterious element had the following relative abundance. One is 34.1, and the other is, because they are isotopes, atoms of the same element, the same element, the same element. But if you want to, we cannot have different mass for the same element in the periodic table. As a result, we have to take the average, weighted average of this thing. But unlike the other thing, we average the average mass. But average mass doesn't mean that you add all the 3 and divide by 3. No. In the case of weighted average, we have to consider, we call it relative abundance. And relative abundance, the first x1 is 34.1%, and the other is 35.2%, and the other is 36.65%. So the atomic mass of their element is closer to 34.1. If you see the abundance, you must do something like taking the abundance ratio. In the abundance ratio, so the atomic mass of the element is closer to 34.1. The atomic mass of this element is closer to 34.9. The atomic mass of this element cannot be determined without knowing exactly what X is. So first of all, I have to know the mass. Let's say carbon. Let's say carbon. Let's take this example. We have copper. The atomic mass is 63. And another copper, because it is an isotope, the atomic mass is 65. And the abundance is given in percentage. It can be in percentage, like this is 69.15, and this is percent, and this is 30.85%. With this proportion, how can we calculate the abundance of this thing? Simply what you do, you just multiply 63 times 69.15%, which means out of 100, plus, and 65 times 30.85 over 100. So the summation of this thing will give us around 63.546. So this is the atomic mass you are going to see in the periodic table. So this is the weighted average. So according to this one, what is missing here? The atomic mass of the element is closer to 34.1. No. According to this one, if you see, the atomic mass of this element is closer to 34.9. The atomic mass of this element cannot be determined without knowing exactly what X. A mass of spectrometer would not be helpful in determining the percentage of the isotopes. The atomic mass of this element is approximately 35.5. Now, according to this one, where do you think? Just logically, you can logically answer this question. 34.15% and 35.20 and 36.65. So it's around between 34 and 36, possibly. So 34.1, it cannot be 34.1. It should be at least 34.9, maybe. The atomic mass of this cannot be determined without knowing, and the atomic mass of the element is approximately 35.5. Before we answer this question, let's get to the point of how to calculate weighted average. This is how you calculate. And similar questions we are going to see, we are going to answer these questions.